The first example of injection vulnerabilities that we're going to talk about is OS command injection. As the name suggests, these vulnerabilities allow us to execute system commands on the target web server. So, as mentioned earlier, a website is simply a computer that is hosted on the cloud. This computer, just like your computer, runs an operating system, such as Windows, Linux, or Mac. Therefore, command injection vulnerabilities allow us to execute system commands on that computer. So if the target computer is Windows, you'll be able to execute Windows commands. If it's Linux, you'll be able to execute Linux commands, and so on. So for example, if the target web server runs Linux, which is one of the most common operating systems to run on web servers, then you'll be able to execute any terminal command or any Linux command on the target web server. Therefore, as a result, you're going to be able to compromise the application and possibly the whole computer or the whole server. And in many cases, you'll even be able to compromise the whole network that the target computer or the target web server is connected to. Because if you've done any of my courses or if you have any Linux or Windows experience, you'll know that you can do so much using the command line. But anyway, in most bug bounty scenarios, all you have to do is display impact. So all you have to do is show them that you're able to execute a system command on the target. And that's enough to show them that the target is vulnerable and to get your bounty. So let's have a look on a simple example and we'll build up on that in the next lectures. As usual, I'm going to include the link in the resources and I'm just going to open it in a new tab. And as you can see, a simple shop website, and as usual you should test every single functionality, but I know the vulnerable feature is in the product details page. And if you go down, as usual, you want to check out the normal behavior of the website. So we have a stock checker in here that allows us to check the stock in whatever location you select. So for example, if you select Paris and click on check stock, it will show you that they have 73 units of this product. Pretty cool. Now, usually the next step is to turn on our interceptor in the proxy and send the request to see all of the data that is being sent, analyze it, and see if we can modify user data to manipulate the execution of this application. Now, if we click on the inspector in here, we can see that we have two body parameters that we can modify as users and manipulate, and they are the product ID and the store ID. So you can double click any of these values and modify them in here, or you can close this and modify them in here in plain text. So as mentioned before, everything that comes after the equal sign should be tested for all of the vulnerabilities that you learned and that you will learn in the future. So this will take a lot of tests and a lot of trial and error. Therefore, instead of having to click the check stock and intercept it in here every time and then modifying it, to make the process easier, we're going to right click this and send it to the repeater. I explained what the repeater is and what it does previously, so I'm not going to explain it again. But basically, as mentioned before, it allows us to modify the requests in here, click on send, and see the response and the result in here, so that we can easily modify requests and test for vulnerabilities and see the response that we get. But before doing that, again, as usual, we want to send a normal request and see the normal result. So this is a normal unmodified request. And as you can see, once we send a valid product ID and a valid store ID, we get the amount of stock available in that store for the selected product. So as usual, you want to manipulate the values after the equal sign and test for all of the vulnerabilities that you know. So the first one we have is the product ID equals 3. And now because we're testing for command injection vulnerabilities and because I already know that this is vulnerable, I'm not going to waste your time testing for stuff that doesn't exist. So the first parameter that we're going to test is the product ID parameter in here, and its value is 3. So we're going to simply send a normal system command. An example of this would be the uname command, which gives you the operating system that is running on the target computer if it was Linux or Unix based. And to do that, I'm going to put a semicolon followed by that command, which is uname. Now, the reason why I put the semicolon in here, because semicolons can be used in the terminal to concatenate commands or join commands. So there's a number of special characters, and we'll talk about that more in the next lecture, that can be used in the terminal in order to execute multiple commands in the same line. Let me show you a quick example. So I have my terminal in here, and I can basically do uname to show the version of my kernel, which is Darwin, and I can do pwd to show my current working directory, which is users Zeus. And I can combine both of these commands, so I can do uname semicolon pwd, and because I use the semicolon in here between the two commands, it's going to execute the first command, show me the result, and then execute the second command and show me its result. So let me show you in here, and as you can see, we get the results of executing the two commands. So what we're doing in here, we're saying if the target application is executing a system command, we want to add a semicolon to inject the second command that we want to run. And in this case, it's the uname command. So we're going to hit send to send it to the target. And as you can see, we get nothing. So we don't even get the stock value, but we also don't get the result of executing our command. Therefore, we're going to move on to the next parameter that we have, which is the store ID parameter. And similarly, we're still saying comma uname, the command that we want to execute, and we're going to hit send. And perfect, this time, as you can see, we're getting the stock amount plus the result of the execution of our command. So now the result is saying Linux, because the target web server is running a Linux operating system. So to verify this also, you could do pwd, for example, to get your working directory. And as you can see, we're getting our current working directory. So from here onwards, you can replace this with any system command that you want to execute on the target system. And this could be very devastating. And I show this in my website hacking course, because you can basically gain full control over the target web server. You can gain full control over the other applications installed on it, and possibly even compromise the internal network that the target web server is connected to. In a pen test, you have to do this. It would be very useful to include in your report, but in most bug bounty programs, you actually don't need to do this, because by simply executing any command on the target web server, you're able to display impact and you're able to prove the existence of this vulnerability. So you will be awarded by simply displaying this impact.